Good day, friends. Welcome back to Nelly Max Concept. My name is Nelson. Today, we are going to continue with our lessons on binary operations. In our last lesson, we defined binary operations and we solved some examples under binary operations. I would advise you go and watch that video in case you have not done that. Try and go through the lesson because it forms a good foundation for today's topic. Now, we are going to look at the identity property of binary operations. The identity property of a binary operation. This is our topic for today. Okay, let's look at the outline, definition, then problem solving. Okay, before we move to the definition, in case you have not subscribed to this channel, please, I would want you to do so. Hit the notification bell as well so that anytime a new video is uploaded, you will be the first to know about the new video. Okay, like, comment, and share our videos. Thank you so much. Okay, let's keep the ball rolling. Let's look at the definition of identity property of a binary operation. Let's look at the property itself. All right. Given a non-empty set S, if there exists an element E, which is a member of the same set S, such that when it is operated on any other member A of S, the member remains unchanged, then such element E is known as the identity element of set S under the given operation. And the property is given as A operated on E is equal to E operated on A, which is equals to A. All right? Something is happening here. The first element is A, the second element is E, and they are both members of set S. Okay? But here we see that the second element E acts on the first element A, and the answer or the result is A, which is the first element. What does that mean? It means this second element E does not have any effect or impact on the element A. That is why what is returned is A. Okay, so we may be given a set that has such element. So if such element exists in any set, okay, we call it the identity element of that particular set. The identity element, if it exists in a given set, is always unique. I will explain that in details as we go further. The identity element for set of integers under addition is 0. Let's explain that. 1 is an integer, a positive integer precisely. 1 plus 0 is equal to 1. Can you see? So, you see, the second element, which is 0, acts on 1, okay, which is the first element, and the answer is 1. Let's look at another instance before we draw a conclusion. Now, minus 3 plus 0 is what? Minus 3. Minus 3 is an integer, 0 is the second element. So 0 is acting on minus 3 to return minus 3. So what can we say about 0? Okay, so you see that this 0 does not have any effect or impact on minus 3. So you see that for set of integers under the operation of addition, okay, under addition operation, the identity element is what? Zero. That is that member of that set that will not have any effect when it acts on any other member of the same set is what? Zero. So I guess at this point it is clearer. Okay, let us proceed. Also, the identity element under multiplication is 1. Okay, let's see why. 2 times 1 is 2. Minus 5 times 1 is equal to what? Minus 5. Okay, you see, uh, still in the set of integers, it is also true for set of real numbers, set of natural numbers, set of integers, okay, or even a defined set. It is also very true. All right. So 1 is the identity element of set of integers, real numbers, natural numbers, rational numbers under multiplication operation. Emphasis again on multiplication. Okay. So 2 times 1 is equal to 2. Minus 5 times 1 is equals to minus 5. You see that the identity element is unique. It is true. Okay? Any number, any real number, any integer, any rational number, okay, times 1 returns that same number. So the identity element of any set under any given operation is always unique. Okay, we are going to proceed with examples. We are going to solve some questions on identity. So let's look at the first example. Example 1 says, an operation star is defined on the set of real numbers by A star B equals to AB plus 2 open bracket A plus B plus 1. Find the identity element. Find the identity element. Option A, 2. Option B, 1. Option C, minus 1. Option D, minus 2. Now let's look at the solution. Okay. Um, so for any A element of set of real numbers, the identity element E under the operation A star B equals to AB plus 2 into A plus B plus 1 is, look at the logic here. Anywhere you see B, put E. Because in our property or definition earlier, it was A star E. Okay, so the second element is always regarded as the identity element. So we're going to substitute B with what? E. Is that clear? All right. So we have A star E is equals to AE, no more AB. AE plus 2 into A plus, okay, no more B, plus E now, plus 1, equal to A. You see? Because in our definition, it is A star E equals to A. So we always return A. It means the identity element E acts on A to return A. Is that clear? All right. So we proceed. So we're going to solve this. We're going to solve AE plus 2 into A plus E plus 1 equals to A. All right. All right. Don't forget, in our first lesson on binary operation, on the definition, you learned that that star or the binary operation is always suggestive. It tells you what to do. So in this case, this operation star tells us to multiply the first and second element together. Then we multiply, we are going to add the first element, the second element, and 1 together, then we multiply by 2. That is what this operation star is prompting us or is telling us to do in this case. So the difference here is that we are replacing B with what? E, because we are talking about identity here. I guess that is clear enough. All right, let's proceed. So we have AE, let's open this bracket. We have AE plus 2 times A is 2A, 2 times E is 2E plus 2 times 1, 2, then equals to A. Okay, in this case, we can actually um, collect like terms. Since we are looking for E, the identity element, so let our E terms be in one side, then other terms that do not contain E should be to the right hand side. Okay, so we have AE plus 2E equals to A minus 2A minus 2. We can factor out E. If you look at the left hand side equation or expression rather, if you look at the left hand side expression, you see that E is common, AE plus 2E. So our E can be factored out. Then we are going to have E into A plus 2 equal to A minus 2A is minus A. Then bring down minus 2. Okay, so since we want E to stand alone, we can divide both sides by what? A plus 2. All right, so we can, why before that we can actually factor out minus. Okay, here we have minus A minus 2, so we can actually write minus open bracket A plus 2. It is still the same thing. Okay, it doesn't change anything. So at this juncture, we can now divide both sides by A plus 2. Okay, so now we have E into A plus 2 all over A plus 2 equal to minus open bracket A plus 2, close the bracket, then all over A plus 2. So as you can see, A plus 2 can cancel A plus 2, so this can go. Then similarly, A plus 2 can go with A plus 2. So our answer remains what? Our answer is what? Minus 1. Okay, so our E is minus 1. Now let me explain this answer. It means in this particular set, in this set of real numbers, okay, given this operation, so it means any other member of this set, okay, any other member of this set will act on minus 1 based on this operation A star B equals to AB plus 2 into A plus B plus 1 to return the same element. I don't know if you got what I just said. Okay, so it means any other member of this set under this operation, don't forget, under this particular operation, under operation A star B equals to AB plus 2, open bracket A plus B plus 1. Okay, it will act on minus 1, then it will return the same element. Okay, so that is what we are saying, and it is unique. Okay, so this identity element minus 1 is very, very unique for this particular set and the operation. Okay, all right, let's check the second example. Mathematics, the higher we go, the easier it becomes. Okay, sometimes if example 1 does not convince you, example 2 can bring up the conviction. All right, so let's check the second example for today. Okay, example 2. If the binary operation star is defined by m star n equal to mn plus m plus n for any real number m and n. Find the identity element E under this operation. Here are the options, and let's look at the solution. So I'm not going to say so much here because so much explanations have been given in our previous slides. Okay, of course, write down the formula. This formula is so important. The next thing is to define your identity property with respect, okay, to this formula. Okay, you define your identity property with respect to this formula. It means in this formula, anywhere you see n, put e, because your n is the second element and we are looking for the identity. So we're looking for the identity element. So replace your n with e. Let's do that. So m star e is equals to me plus m plus e, then equals to m. Yes, because whenever identity element acts on a member of a set, the answer is always the member of that set. So m star e will always give us m. So let's proceed. So we're going to solve this. Okay, so in this case, we have me plus e, then our m will go to the right hand side. We now have m minus m. So me plus e is common, we can factor out e. So we have e into m plus 1 equal to 0. Dividing both sides by m plus 1 so that our e can stand alone. We now have e into m plus 1 over m plus 1 is equals to 0 over what? M plus 1. And our identity element becomes 0. You see, that's very, very simple. All right, let's check example 3. Example 3 says the identity element with respect to the multiplication shown in the table below is dash. Okay, this is a binary operation table. We are going to look at the solution. Anytime you have this kind of problem, it's very, very easy to solve. Very, very easy. If you're looking for the identity element, it is very, very, very easy. Once you can define identity element, you are good to go. All right. Now, let's look at the solution. Now, you see that these KLM are our first element. Then KLM, this horizontal letters are our second element. Now look at what is happening here. K operates on K to return L. K operates on L to return M. K operates on M to return K. That should suggest something to you because we define identity as A star E equals to A. Okay? That means the identity element here is anything that K will act on to return K. Anything that L will act on to return L. Any element that M will act on to return M. So if such element exists here, then that element must be the identity element of this multiplication table here. Okay. Now let's look at the explanation, the solution. You see that K operated on M returns K. Look at it. K acts on M to return K. Let's check another one. L operates on M to return L. As you can see, L on M is equals to L. Let's check M also. M operates on M and the answer is M. It is only M, this second element M, that satisfies this condition. Okay? As you can see, if you say that L is the identity element, then it means K operated on L should give us K, but it's giving us M. So L cannot be the answer. Likewise, K cannot be the answer. So we tested M with the three elements, with three different elements, and the answer is consistent. So M is the identity element. Okay, M is what? The identity element. So it is very true because M is the element that acts on each of K, L, M, and it returns K, L, M respectively. So it doesn't have effect on this element. So that is it. There's a shortcut to this. The shortcut is this. Just if you're looking for the identity element of this operation, this multiplication table, what you do is you are given KLM. So look for any column that has KLM in the same arrangement, in the same order. Look at KLM. Look at KLM. So any member, any element above them or above the column or the vertical line is your identity element. Look at it, KLM, KLM. So this M above is your identity element. It is that simple. Okay, let's look at the next example. Example 4. A binary operation is defined on the set of real numbers by A operated on B equals to A plus B plus 4. Find the identity element of the operation. Okay, look at the options. Okay, let's look at the solution. Solution. Our This is the working formula. If you have seen my first video, you would have heard me say this. So this is our working formula, but we are going to define the identity property with respect to this formula given to us. So anywhere you see B, you put E, then equate to what? A. That is it. So A operated on E is equals to A plus E plus 4 equals to what? A. Okay, so let's solve this. We're going to have A plus E plus 4 equals to A. We're looking for E, so our A and 4 can go to the right hand side. So in this case, we have what? E is equals to what? A minus 4. And our identity element is what? Minus 4. Very, very simple. It is always easy. Just know that your B or the second element will always be replaced with what? E, which is the identity element. Then you always equate with what? You equate the first element. Okay? So it is just so simple, not difficult at all. This is the whole idea of identity element. Okay? Whatever working formula you are given, always redefine your identity property with respect to that working formula. That is, anywhere you see second element, insert E, okay? And other things should remain the same. Then in the right hand side, put the first element, and you are very, very good to go. All right. So at this juncture, I'm going to give you just two questions to solve to check your understanding of the class. We have the first question here, and this is the second question. Try to solve these questions, and I want to see your answers in the comment section. Okay, try the questions, they are very, very cheap. Okay, in case you maybe cannot solve any of them, maybe you may need to watch the video over and over, or you can just let me know. I can still be of help. And if there's any question on this topic that you came across and you could not solve it, please, I would advise you can bring it up to the channel. We can be of help. Thank you so much. You are always welcome with your questions. Um, we are here to help you. All right. Thank you so much for your time. Don't forget um, to subscribe. Okay. We are going to meet again in the next lesson. In the next lesson, I will be treating another property of binary operation. Okay. If you want to know that, keep on checking on Nedima's concept. Okay. Very soon we shall drop that um, lesson. Okay. On the next property of binary operations. Thank you so much. Kindly subscribe to this channel. Take care.